Okay, so I'm Ryan Mullins, and this is my sliding IF receiver design on 65 nanometer CMOS. So I guess I'll start with the LNA design. Okay, yeah, here's the LNA design. It's a cascode LNA with inductive source degeneration, some input matching. There's also some matching that's done off chip, as you can see here on the input of the entire receiver block, um, and then some output matching as well. And then here's some of the results. So we have EMX post layout and pre-layout. And you can see pre-layout, we have a center frequency of 15 gigahertz, a gain of around 21.4, and a noise figure in the milli-dB around 980 milladecibels. Then here we can see our compression points for various EMX post and pre-layout, and then our gain circles and noise circles as well. Um, okay, here's the layout of the LNA. Here's the mixer. It's a double balanced passive mixer, and here's the layout as well for that. And then we have our LC voltage controlled oscillator shown here. This is pretty simple, just a cross-coupled pair NMOS and PMOS cross-coupled pair with varactors. And here's the layout of that. And then we have our division circuit here, which is an injection locked frequency divider. And then we have a second one which has quadrature output. And yeah, here are the results. The VCO oscillates at 14 gigahertz, and then when it gets buffered, it goes down to 12.8 gigahertz. And then here's the layout of the quadrature output divided by 2 injection locked frequency divider. Yeah, so as I mentioned, here's the schematic of everything laid out. We have the LNA, the mixer going into 2 more mixers, and then we have our VCO, 2 divided by 2s. The last one has quadrature output. And then yeah, and here's our test bench for that again at the input matching and the 4 quadrature outputs, and then here's the layout where EMX simulations are currently running. So yeah, thank you.